Okay, so here's part C.
Yep.
So we got our shape. Can you just
Yeah.
kind of hold that shape? Here, maybe sit it down gently. Here, I'll get down on the ground for a second. So initially we had a regular pentagon.
Yep.
And we had this line come across it. I would like you to tell me what you know about the angles in a regular pentagon, and maybe we can identify what the angles in this triangle are.
Well, I know the angles in a regular pentagon, they add up to, I think they add up to 540 degrees.
Okay, how come?
Well, because we found an area formula for an n-gon, it's n minus 2 times 180.
Yeah, not the area, but the sum of the angles.
Oh yeah, the sum of the angles.
Right, so the area, the angles in a pentagon add up to 3 times 180. So each one of these angles is how big?
It's a 108 degree angle.
108 degrees. Okay, so 3 times 180 over 5.
So,
Do you know a good way to divide by 5?
well, you divide by 10 and then multiply by 2.
Okay,
So that would be 3 times 36.
so 3 times 36.
Which is 108.
It's 108. Okay, 108, 108. This is a 108. But how are we going to figure out what these angles are? I know you know how to do this, but I want to see what your brother has to say. Okay? Okay?
Mm-hmm.
You'll get plenty of time in a minute. What do you think? How are we going to figure out these other two angles in this triangle?
Well, if this line is straight, I
Yeah.
think, well, this line is going to have to go from the midpoint of this angle to the midpoint of this angle.
Okay.
Because if it was bent, then it would go kind of off to the side.
All right. Interesting.
So that would kind of make sense for it to be the midpoint.
All right.
That splits those angles in half.
All right. So what would that mean those angles are?
They would be 54 degrees.
Okay. Now, does that make sense? That those would be 54, 54, and 108?
Mm-hmm. Well, angles in a triangle add up to 180.
Yeah, angles in a triangle add up to
But
180.
this is over 180.
Oh, but it's over 180. Okay.
Hmm.
But that's all right. We learned something. What did we just learn about this line segment here?
We learned that they don't cut those angles in half.
Does not cut those angles in half. But can we figure out from there what those angles must be?
Well, it's 180. We can subtract 108 from 180. We get it's 72
Okay.
left. And these are both equal angles.
How come those are equal?
Because this line is straight.
Yeah, it is straight, but I don't think, like, if I have a triangle like this, I always have straight lines. But that doesn't mean the angles necessarily are equal. What makes
because
those angles
this is isosceles.
Ah, very good observation. These sides are the same way. So it's isosceles. So each of those angles end up being
36.
36. Okay, so we have a 36, 36, 108 triangle.
Yep.
Which is a pretty interesting triangle. But we found a couple other triangles in here that we thought were similar to it. Where's another one?
Kind of maybe like that.
Okay, and even another one.
Well, this one.
That-
Small.
That really small one here might be a super useful one. Can we figure out the angles in this small triangle?
Well, yeah, I
It's
see a way to do
it's
it.
still isosceles.
It's still isosceles. Good observation. What do you notice?
Well, I noticed that we knew that this angle was 108.
Okay.
And whatever these angles are, it's equal to this triangle. These triangles are congruent.
Okay, interesting.
So we could say that this 2 of this angle plus whatever this is 108.
Okay, yeah.
And then from this angle is 36
Why?
because we have the big triangle.
We already have the big triangle we calculated. Yeah.
And so that means that's 36 because it's isosceles.
Okay.
So that's 108. So the triangles are indeed similar.
They are indeed similar.
Cool.
Pretty cool, right? So horizontal set's actually really helping us here because of the formulas you were just about to talk about. Okay?
Yeah.
All right. Let's talk about those formulas.
Okay.